Hello everyone. Today we will present our course project on boat sanding. This project is a collaborative effort between Nofel Masnoor, Arman Malik and Abdul Rauf. We are group number 3. Our project utilizes a Gazebo simulation environment where we have developed a robotic system to automate the sanding process of an upside down boat. This involves complex maneuvers of both the robot's base and its arm to sand designated areas precisely. Moving on to our project overview, we have set up a simulation in Gazebo. In this environment, we are working with an upside down robot and a robotic arm mounted on a four-wheeled base. The primary challenge for our robot is twofold: navigating the base and operating the arm. Overall, 596 points on the boat's bottom needs to be sanded. To achieve this, our project uses a two-phase planning strategy. The first phase plans the movement of the robot's base to optimal locations. The second phase involves planning the robot's arm movement to reach and effectively sand each point. Now we focus on planning the movement of the robot's base. The process starts by selecting a random point from the boat's bottom surface. Once a point is selected, we determine this point's horizontal orientation in the xy plane, which is represented by the green arrow in the image. Next, we calculate the opposite of this horizontal orientation, which is where we want the robot's base to face. The blue arrow shows this opposite direction. Finally, the robot's base is positioned 1 unit away from the selected point in the direction of the blue arrow. This allows the robotic arm to reach and operate on the point effectively. The next step is to move the robot's base to the designated position. The process is visualized here. A red arrow shows the direction in which the robot's base needs to move. Colored points represent the path planning and trajectory that the base follows to reach its destination. Rotation axis shown by the colored rings indicate the orientation adjustments the robot makes during its movement. Once the base is correctly positioned, it sets the stage for the next phase, which involves the precise operation of the robotic arm to sand the specific points. Moving the base accurately is crucial as it ensures the arm can reach all the required points without any issues. Once the robot base is in the correct position, the next phase involves planning the movement of the robotic arms and effector. Let's look at how we plan this. We start by identifying all the points that are within 1 unit of distance from the robot's current base position. These points are considered unexplored and are our targets for sanding. We then cluster these points together using the traveling salesman problem. We plan the optimal path for the arm to follow. The starting point for this path is always the robot's current base position. The robotic arm plans its movement to reach each point in the sequence determined by the TSV. Finally, for each point, the n effector is positioned 0.1 unit away from it and oriented opposite to the point's original orientation. With our robot's base correctly positioned, the next crucial step is to execute the planned movement of the robotic arm. This slide shows how the arm moves to perform the sanding task on the boat. The profiler provides real-time data on the robot's interaction with specific points on the boat's underside. Each point the robot interacts with indexed and detailed with its 3D position and orientation. The profiler tracks the status of each point, whether it's reached, unreached, or it's still being processed. It also details the cluster points that the robot attempts to send, showing the total number of points, the number successfully reached, and the remaining ones. As we now watch a video demonstration of the robotic system in action, let's focus on how each component we have discussed comes together to achieve this task of sending the boat. Notice the robot's base maneuvers across a simulation environment. This movement is based on our planning to optimize the reach and effectiveness of the sending process. Pay attention to how the robotic arm operates. It adjusts its position and orientation to effectively sand each designated point on the board's underside. The video also showcases the adaptability of our system based on real time data from our profiler. So, as we conclude our presentation, I want to express my heartfelt gratitude for your attention and interest in our board sanding project. If there are any questions, please feel free to ask. Thank you once again for your time and engagement.